All right, simplifying complex fractions. First of all, a complex fraction is a fraction with a fraction in its numerator or its denominator, or both. The examples you see here have a fraction in the numerator and a fraction in the denominator. Okay, and so that middle fraction bar is telling us that we are going to be dividing by 6/7. So dividing, as we've already studied, is the same as multiplying by the reciprocal. So we will be ultimately multiplying by the reciprocal. Same as we did with dividing. So I started with an example just from elementary school, 2/3 divided by 6/7. No variables. Should be pretty basic. So if this is our dividing and multiplying is dividing by the reciprocal, this turns into 2/3 times 7/6. When we multiply, we'll multiply straight across. Since this is a numeric version, there's no factoring needed. We can just multiply 2 times 7 and get 14. And 3 times 6 and get 18. And then we can see that those numbers do simplify. If we divide them by 2, we'd have 7/9. So we have the answer 7/9. Okay, so let's move to an algebra example, slightly, since it has x's in it. Again, the middle fraction bar is where our division symbol would go. So this is telling us to do 3 over 2x multiplied by the reciprocal of 9 over 5x. So 5x over 9. Okay, so same as we did with dividing, we can simplify by crossing out factors that will make 1. So remember 2x is 2 times x, and 5x is 5 times x. So either here or at the end of the problem, we're going to want to make sure that we divide out x and x, because they make 1. We can also, if we think of the 9 as 3 times 3, we could realize that we could simplify this 3 with one of the 3's from the 9, and so that would leave us with 1 instead of the 3, and 3 instead of the 9. Okay, so then let's multiply across. All we have left on the top is a 5. And all we have left on the bottom is 2 times 3, so 6. 5/6. Okay, let's continue with some more algebra examples. Alright, again, the middle fraction bar is where the division symbol would go. So this is asking us to do x plus 2 divided by x, and then multiply by the reciprocal of the fraction on the bottom. So 3x over x minus 2. Okay. So remember, think of these as factors. X plus 2 is a binomial factor. We can't break that apart. Same with x minus 2. But x is a factor, and 3 times x. 3 and x are both factors. Remember, factors are parts of a multiplication problem. So we can simplify x divided by x because that makes 1. Then multiply across. And what we have remaining is 3 times x plus 2 over x minus 2. The binomials are not identical because one is positive and the other is negative. So we can't simplify it. Remember, you keep the whole factor or get rid of the whole factor. You can't get part of it to simplify. Okay, final example. Okay, that fraction bar is again where the division would go, and dividing is the same as multiplying by the reciprocal. So we're going to have 5 over x plus 2 multiplied by x squared minus 4 over negative 3, the reciprocal of the fraction on the bottom. Okay, now it's a multiply problem, so I look to see if anything factors. 5 does not factor. X plus 2 does not factor. X squared minus 4. Now that I notice is a difference of squares, so that does factor. X plus 2, x minus 2. And a negative 3 does not factor. So, simplifying. Things that make 1. This x plus 2 and that x plus 2 would divide and make 1. So that leaves us with 5 times x minus 2 over negative 3. The 5 and the negative 3 would simplify if they could. Say if it were 6 and negative 3, we'd be able to simplify that, but since it's a 5, we cannot. So that is the final answer on that problem.